Let's talk about chemical equilibria. Previously, you've really only seen chemical processes in terms of complete reactions, where you have all of your reactant converted into product. In truth, that rarely happens in the real world. More often, some reactant changes into product, but some reactant stays the same. This is not because the reaction is simply taking its time and will eventually go on to completion, but rather the reaction has run its course and has achieved equilibrium. Sometimes we think of equilibrium like a balance or a seesaw, not necessarily equal parts on either side, but instead unmoving on either side. While that's a pretty good way to think about it, chemical equilibrium is actually a dynamic process. What I mean by that is that a system at equilibrium is still making products, it's just also making reactants at the same rate. As a result, the amount of products and reactants are effectively constant. Recall rate law in chapter 13, where K is the rate constant, and these brackets indicate concentration of a substance. Now, let's clarify here that we're talking about the forward reaction rate. And in equilibrium, remember that we also have a reverse reaction going on as well. For that, the rate can be described like so. So knowing what we do know about the dynamic process of equilibrium, where the rate of the forward reaction is equal to the rate of the reverse reaction, we can combine these two rate equations and get Kf reactants equals Kr products. We'll now rearrange this so that the Ks and the Rs, or so that the Ks and the concentrations are on the same side. And we get this ratio of Kf over Kr, which we're also just going to call now capital K, the equilibrium constant. So this is a constant to describe what exactly the ideal ratio of products and reactants is for a given reaction at a certain temperature. A large K value, as in something much greater than 1, would indicate that the equilibrium favors the forward reaction, making more products, which is in the numerator, and using up the reactants, which is in the denominator. Vice versa, a small K value means that the forward reaction does not strongly occur, and instead we're left with more reactants and less products made. We'll talk more about what factors affect equilibrium in later videos.